Hey guys, welcome to another episode. This is the fourth part of the making the chain reaction game with the Godot Engine. And now till now we have tackled with the data layer, that is just finding out the corners, finding out the edges, and also finding out the middle pieces, and then incrementing all of the around edges. We have tackled the cases as well. So now one extra thing that I did before starting this episode is implementing the recursion as well. So I also told you that the pieces next to the actual space, that is the space next to the actual space, that is the one to the left and one to the right, if they also reach the equilibrium, we'll have to explode them as well. So I'm doing the same thing here. I'm calling the explode function inside that explode. So this explode will also check if that has reached an equilibrium in all three of these cases, big cases. So the explode function takes in a simple vector too. So I pass the same arguments as this one, the set of these variables over here. So if there are two increments like this, incrementing one on these spaces, so call the explode functions for those same two spaces as well. So I've done that exactly. There are three here and three explode functions, and similarly there are four increments over here and four explode functions are being called. So the next thing that we will tackle is the visuals. All right, so we'll just test this. I'll just hit play. So now I can just test whether the tile next to it is getting exploded. So we'll bring one next to the corner to the equilibrium. So I'll put two atoms over here. So this means that this number became 2, it got added, and now as this is 2, I'll add 1 over here, so it added a 1. Now if I press another 1 over here, put another atom, this will explode, and again this will reach the equilibrium and it will explode back. So ultimately we will have one atom in the corner space if this works. So I'll click over here. So as you can see, we have one atom in the corner space. So this is indeed working. So the explode is getting called for the neighboring spaces as well. So that is cool. So next we will be tackling the visuals. We'll just show the visuals. So for that, the way I'm going to do this is I'll just declare the visuals. I'll declare the references like this, just like I did for the spatial button. So I'll just name it var single sphere variable 2 sphere sph, var 3 sphere, and variable 4 sphere. So these are going to be four different scenes. So when we actually hit an atom, hit a space, this an instance of single sphere will be put there, and again if we hit on that same space, this single sphere which has already been there will be deleted and will be replaced by an instance of 2 sphere. So again when it explodes, we will animate, we will set this 2 spheres such that there is an animation linked with it, and that animation will be played, and then the other neighboring spaces will be replaced by whatever corresponding sphere the data layer has. So first, to do referencing, we'll first have to create the scene. So to create the scene, hit the plus icon here, and I'll go to the 3D space, and now I'll add just a mesh instance for the single sphere. So I'll just name this as single sphere, and so this will be a mesh of the type sphere. So I'll set it over here. So yeah, it just hanged. Cool. So as you can see, this sphere is 2 units wide. We don't want it to be that wide, so I'll just bring this down to 0.5 in all the three axes. Go to the transform scale, So if we do this size, the edges of the grid will touch to the edges of the sphere as well. So we want to reduce it further, so I'll just make the scale somewhat 0.2 probably. So this will be one sphere. I think this is good. I'll just save this scene, Control S, single sphere.tscn, that is fine. And now we have an instance of single sphere. So we'll go back to the chain reaction, go to the scripts over here. So we'll reference the single sphere to that scene. So is equal to use the function preload, just like the spatial button over here. And now we'll reference the single sphere.tscn. So this single sphere should be spawned whenever we click on the button over here. So to do that, to spawn the visual layer, that means I'll just name a function. I'll just call a new function which handles the placing of all the spheres in the game. So I'll just name this as replace spheres or replace sphere, because it's working on only one sphere now. So this will take in probably a position, at what position it is supposed to spawn the sphere, and also a num, which is the number of spheres it needs to spawn on that place. So where shall we call this function? So I think we should call it after. So yeah, we'll just write the function first. So we'll do a check if num is equal to 1. So that means we need to spawn a new sphere here, and so var s, I'll make a new variable, that is single sph dot instance, to actually make a new instance of a scene. So if I want to make a new instance of a scene, you use the instance function. If you want to make a new instance of an inbuilt class, which is, for example, the space over here, so this is a very tiny class, but there will be bigger classes in more complex games. So if we want to create an instance of that, we use the new function. All right, so here we want to use the instance because it is a scene. Single sphere is a scene. So after making s, I have went ahead and created a spatial node over here just below chain reaction. It is called as spheres. So this is just like spatial buttons. It's designed to hold all the spheres in the game in an organized manner. So I'll reference that by $spheres dot add child s. So after adding it to the scene tree over here, that means this single sphere is now visible, right? So after adding that, single sph dot, I'll change its translation, not single sph, it is s, because it's the object that we are referring to, the instance that we are referring to, not the scene itself. S dot translation is equal to a new vector3. So this will be, the x will be the up to down position, that is pos.y, comma the y, that is the depth, will be 0.5, because our lower layer of the grid is at 0 and upper layer of the grid is at 1, so this needs to be at 0.5. And the z will be the left right, that is the position.x. So if the number is 1, I think this should work, but we are not calling the replace sphere yet, so go ahead and do that. I think this should be called after doing all of the changes in the data layer like this, right? So I can call it right over here with the position pos and the num, which is same as board data of position.x and position.y. So whatever the number of spheres is, will be updating in the replace sphere. But the problem is this won't be reached because there is a return statement over here, right? So I think this, as this is the last case, I'll just remove the statement So if it executes, it has to replace the sphere here. And what I will do, I'll just comment here, replace the visuals of the sphere to the current board data values, right? So this function does that. I'll just copy this, place it before this return statement, and also I will copy this and place it before this return statement. See, the problem is we can actually use this replace sphere and put it over here because we don't have to tackle any return statements. But the problem is, yeah, we have to first update the data layer and then update the visuals, right? So that's why we need to put it in between these. So before returning and after updating the data layer. So that's why we have a lot of calls to replace sphere. So I think this should work. I will just press play. We'll see if there are any errors. So if I place, okay, so object and int, so this is apparently an object. So yeah, we have to pass the dot n over here, not just the object itself. So I'll just add dot n to all of the replace sphere calls. So here, yeah, and that's it. So now if I press play, now as you can see, the spheres are getting spawned wherever I click, even in the corner values like this, right? So, and it obviously needs an offset of 0.5. So we'll make that quick fix. We'll go to the replace sphere. After we translate it by an extra 0.5 and here by an extra 0.5. So now if I hit play, it should be exactly on the center like this. Cool. Okay, so now what we will be doing next is we'll be replacing this sphere, which is the one which we spawned, with another instance of another scene which is called as two spheres. So we'll be referencing that over here that we stored. So I'll create a new scene first, and now the single sphere just contains one single sphere, one single mesh instance. So it has only one sphere, so we don't need any children. So now because it contains two spheres, two mesh instances, so I'll just create a new spatial node. I'll call this two spheres. So this will be just a holder for the two spheres. And now I'll add a new mesh instance. And then the same way as we did for the single sphere, I'll select the sphere instance. And again, the scale, I'll set it to 0.2 as I did in the single sphere again. So the scale is reduced now. And now what I'll do is select the mesh instance, hit Ctrl D. So this duplicates the mesh instance twice. So that is a handy shortcut. So the translation of the first sphere, I'll just increment this by, I'll just change the x by 0.1 because the radius of the sphere is 0.1, the diameter is 0.2. I'll just increase by the radius so they overlap just in an organized way. So this will be minus 0.1. So now as you can see, they look like two atoms which are fused together. So nice look. And now I'll just save this scene as two spheres.tscn. So now let's go back to the chain reaction. I'll first reference this to the preload with a preload, that is, I'll give it the two spheres.tscn. So after doing this, the one problem over here is after we put the single sphere instance like this in the replace sphere, we are not having a track of where it is. So we should actually store its reference, because when we instance at two spheres, we need to delete a single sphere, that single sphere which was there already, right? So we need to have a reference for that. So what I will do is, we in the whole board, if there are a lot of single spheres, if the chain reaction happens, we need to store the reference for each one of the current spheres that are in a space. So just similar to the board data, so I have just commented this as a data layer. I'll just comment this as a visual spheres, something like that. So visual spheres layer. All right, so this will be called very similarly board spheres. It will be a two-dimensional array, just like the board data. So board data holds the instances of space, right? So just like that, board spheres holds the instances of whether it's the single sphere or two sphere. It holds the instances of the visual mesh instance that is needed to be deleted or changed or whatever. So just like we populate the board data array, it is not BORD. So I'll do a comment, populate the spheres, okay, board spheres array, just the similar way, board spheres array. So I'm going to copy the same thing and paste it over here. So the same thing from left to right. This will be SARR spheres array, just to be consistent. Spheres array like this. So we will append a new instance of we cannot append a null like this, so it will just be awkward. So what I'm planning to do is just creating a whole bunch of single sphere instances, all right, and then appending it to the array. So what we'll do is we'll append it to the array. We'll also set its translation to the respective places in the array itself. After we do this, what we'll do is we'll hide all of the single sphere instances. So there will be a single sphere instance already there, but it will not be visible. So we'll check if that single sphere instance exists in that array, and we don't need to actually create a new instance over here. We just need to enable whatever's there. So it'll be a tiny bit of optimization. So instancing the whatever the sphere before, and then just enabling it when you need them. So you don't need to create the objects on the fly. So there's a tiny bit of optimization that we can do. So I will create a new variable where s is equal to the same thing as it is there in the replace sphere. We need to cut this. Okay, I'll just copy this and then go up and then paste this. So we are creating a new single sphere instance. We are adding the child as a sphere, and we will also set its translation to a new vector 3. So this will be the y will obviously be 0.5, the z will be from left to right, so it will be I, and x will be from top to down, that is up down, that is j. Okay, so j, so obviously we need to give an offset as well here, else it will spawn at the edge of the grid. So j plus 0.5, I plus 0.5. So now we can append this s to the array. Okay, so after we append, we just need to hide it as well. So s dot, I just call the function hide. So this is the same way as clicking this eye icon over here. So if I go to the single sphere, if I go to the 3D view, if I press the eye icon, I can't see it, it's just hidden, right? So it's the same thing using this function by code. So this should not be board data, it should be board spheres, and this should be SARR, sphere array. So I think there is no problem with this. And yeah, when we go to the replace sphere, if the num is equal to 1, and we will check if the board spheres at the position pos.x and position.y is not equal to a null. So that means there is a single sphere instance already hidden there. So what we will do is we'll copy the same thing, and this is a reference to the sphere as well. So to show the to get back this eye icon to show, we will use the show function. So if there is no instance of board sphere inside that space, we will create a new instance of single sphere and we will set its translation. So I think this is fine. This should work as before. I'll just hit play now. So cool. So now what we are doing is, there are already a lot of spheres here, and when we click, they will just enable, they will just show themselves. So we are not actually creating a new sphere. So cool. Now we, as well as just enabling these spheres, we also have a reference to them in a big array, which is the board spheres, right? So the replace sphere will be called with a number 2 when it reaches, when any tile reaches a number 2 in the data there. So I'll do an else if num equal to 2. So again, it's good to do this. If the board spheres is not equal to null, then what we need to do is whatever's in there, we need to delete it. So I'll first grab an instance where s is equal to whatever there is, board spheres of s. So now I can just free that instance. So freeing that instance, we have to call the function queue_free, right? So as we did in the, so where did we do this function? Yeah, we probably have not used the queue_free function. So the queue_free function, to actually destroy an object, that is an instance, the instance of something, instance of a scene, there are two types of functions, which is the free function and there is the queue_free function. So what just the free function does is just if there are a lot of objects that you need to delete at once, so if you use the free function, they are going to be deleted immediately. So there will be a lot of a bit of performance lag, not probably a lot. I not tested this very much, so there will be a bit of performance lag by using just the free function. So else if you use the queue_free function, what it'll do is, you have a bunch of objects you want to delete, it will add it to a queue and then delete them one by one. So that actually saves some computing power. So when you do this, we are queuing that free, and then just copy the same thing and then paste it over here. So now we will make an instance of 2sph. Do we have a reference for this? Why is the autocomplete not working? Yeah, it's over here. So the 2sph dot instance, and then add it again, and then I will set its translation. So after setting the translation, we also need to update this spheres, right? So the spheres will be equal to s. So the same way, so no, what is wrong here? Variable s is already defined in the scope. Okay. Oh yeah, so we are defining it again. So s will be board spheres, will queue that free first. we'll use the same s to actually do an instance. Again, that's fine. After doing this, we'll set it back to whatever the board spheres was. So I think if we just hit play, this should work. So I'll try testing this. So the first sphere is getting spawned. If we click on one of these, as you can see, the sphere that was already there is getting destroyed and it is turning into a 2 sphere. And also the replace sphere is also getting called on the neighboring tiles as well, because it is replacing the spheres. It is also updating the data layer. So if I press on this, as you can see, it is going to split. So again, if I press on this, this should split. Cool. So it is working. So now, just like we did the num2, we'll copy this for the num3 and then for the num4 as well. So we have not made those scenes which are the 3 sphere and 4 sphere set. We will be doing it, but we are actually setting this here itself. So this should be 3 SPH and we should make an instance of 4 SPH over here. So I think that's the only changes that we need to do. So cool. So yeah, the next thing to do is just create those 2 scenes. So hit the plus button over here. Again, just go to the 3D space so you can see. Control A spatial, rename this as 3 spheres this time, and then add a mesh instance and set the mesh to the sphere. Again, set the scale to 0.2, 0.2, 0.2, and then after you do this, duplicate this 2 times. There are 3 of them. So the first one, translation, I'll set it to 0.1, and then the second one I'll just set it to minus 0.1, and the third one I'll just probably set it to 0.1 in the Z. Oh sorry, 0.1 in the Z. I don't know if this is ideal, so I think what I can do is move this in the Z.1 as well. So I'll just move this in the Z point. Okay, this should be minus 0.1 and the first one will be 0.1. Okay, this is also minus 0.1. So after doing this, the green line over here, which is the y-axis, is roughly at the meeting point of these 3 spheres, roughly. So it is all right. So this will be the 3 spheres. Just save the scene, save, and now similarly we'll create the 4 spheres. Control A spatial, and then rename this as 4 spheres. Make a mesh instance, mesh it to sphere, scale 0.2, 0.2, 0.2. Now duplicate this 3 times, and the first one will translate it to 0.1 and 0.1. The second one will be 0.1 and minus 0.1. The third one will be minus 0.1 and 0.1. The fourth one will be both minus, that is minus 0.1 and minus 0.1. Cool. So this will be a set of 4 spheres which are round. Now that I actually think about it, we don't really need to do this because we won't be seeing this anyways, because as soon as the equilibrium hits 4 spheres, it is going to explode. So I'll just delete these 4, just reset this back to 0, 0, 0, and then just duplicate this 4 times, let them be there. So I'll save the scene to 4 spheres. So after doing this, go back to your chain reaction, and then reference the 4 sphere and 3 sphere by hitting the preload function, 3 spheres, reference it, and is equal to preload. This time it's 4 spheres that we created, and this should work fine because we already have the 3 spheres instancing and the 4 spheres instancing. So if I hit play now, it'll be 1, and now when we press this, it'll be 2. So this will be 2. So if we take the middle one, that is 2, and the 3 also will get updated. So when we split this, it will split it into 3 separate parts. So what is happening is we are not testing for, we have to delete what is in the middle, right, when it splits. So we are not handling that. So we basically need to handle for n is equal to 0 over here. So if you go to the replace sphere, we are handling for 1, 2, 3 and 4, but there is no condition for if it's 0, right? So we'll just create that if num equal to 0. We'll do this as an else if. So if the num is 0, what we need to do is just probably delete what's there. Shall we delete or just shall we hide? I think it's better to delete. I don't think there will be another instance when it explodes, so it's better to delete. So I'll just copy these 2 lines of code and then just paste it there. So this means we are just deleting whatever's in that space. So cool. This is getting updated, and yeah, we have to update the board spheres as well. So what can we update this board spheres to? So I think we shall make a new instance of single sphere and then just do the same thing as we did in this part. So I'll just copy these lines and then just go down and then just paste it over here. And then after this, can use the same as so we'll copy this and paste it over here. So the board spheres will have a new fresh instance of single sphere which is hidden right now. So this can also be an optimization. Again, we are prematurely instancing and then just enabling when the num is equal to 1 over here like this. So if we press play now, it should show no sphere if this should be changed to position.y and then position.x. So is there anything else we need? Oh yeah, this sarr.append, don't need to do this, and s.hide is required. So cool. If we need if we press play, let's see, spawning a sphere, and if we hit another one, this should get deleted. Cool, it's working. So again another one. Now if we press on this, these 2 should update itself to 2 spheres. It is doing that, and if we press over here, it shall split it into 3 again. Cool, again 2. So as you can see that it's just jumping all the frames. It's not playing the animation where the split happens and again the chain reaction happens from that spot. So we shall be tackling the animations in the next episode. So until then, if you have any doubts or if you have any queries, or if you want to share something, or doubts and the queries are the same thing. So if you have any doubts and if you want to share something, so just leave it in the comment section below, and till then, just take care. Bye bye.